NASA's Voyager 1, currently the most distant thing humans ever made, has amazed people around the world for almost 50 years since it was launched. It's been sending back important info from the edge of space, helping us understand the universe better. But lately, Voyager 1 has been sending some weird signals that have scientists scratching their heads. These strange signals have caused a lot of debate, with people wondering if they're just technical issues or something way more interesting, maybe even signs of alien life. Let's check out these puzzling messages and see what secrets the universe might be hiding. Humans have always been curious, and that's why we explore space. This curiosity set the stage for projects like Pioneer 10 and 11, which were pretty daring for their time. Voyager 2 launched on August 20th, 1977, from Kennedy Space Center, and it kicked off a whole generation of space exploration. Not long after, Voyager 1 went up on September 5th, 1977, starting and eventually taking it way out past the planets, which totally changed where it was headed and what it found. Each probe is about the size of a small car and weighs around 721 kilograms, heading in different directions at different speeds. On December 15, 1977, Voyager 1 went farther than Voyager 2 because of their different routes. Since then, Voyager 1 has been super useful for learning more about space, giving us findings that have changed how we see the universe. Before talk about the latest discoveries, let's recap some key early wins. Back in 1979, when Voyager 1 was about 265 million kilometers from Earth, it snapped some great photos of Jupiter. By January, it finished a 100-hour study, creating a time-lapse video showing Jupiter spinning. These 3,750 images gave amazing new details about Jupiter's crazy atmosphere and features. During that mission, Voyager 1 found a ring around Jupiter that no one knew about, plus 2 new moons, which gave us better info on the planet. To stay on course and not crash into Titan, a moon of Saturn, the probe had to make a few adjustments. Then, the mission looked beyond the planets, sending the spacecraft into interstellar space at about 325 million kilometers per year. In January 1990, Voyager 1 started looking at interstellar space, pushing past our solar system's limits. During that time, it did some cool stuff, like discovering 4 new moons, Mimes, Enceladus, Teus, and Rhea, and capturing memorable images of the outer solar system. Around February 14, 1990, about 6 billion kilometers from the Sun, Voyager 1 took the famous family portrait, a bunch of images of the inner planets. These 60 photos were added to the hundreds of images the probe already had from getting close to the gas giants. Voyager 2 also had its share of wins. It measured winds on Neptune going over 2,100 km/h, the fastest winds ever seen in the solar system. It also checked out Triton, Neptune's biggest moon, where the temperature was a frigid -391 degrees Fahrenheit, making it one of the coldest places we know. Triton showed signs of icy eruptions, shooting nitrogen gas and frozen stuff up to 5 kilometers high, showing some wild geology. These discoveries really expanded our understanding of what's going on way out in the solar system. Voyager 1 and 2 have been game changers. They found things about Jupiter and Saturn's moons that we never knew. We used to think they were inactive, but the new info changed our minds about their activity. Voyager 2 is the only spacecraft to ever get close to both Uranus and Neptune, which is a big deal. NASA used some tricks to keep these missions going longer, like turning off stuff that wasn't crucial to save power. The mission is expected to last until 2030, marking the end of a great for the teams working on it. Voyager 1 and 2 were well designed and engineered. The probes would slowly rotate to avoid blurry pictures. Even before they got to the outer planets, they started sending clear images of Jupiter, showing its swirling clouds and the Great Red Spot, a massive storm that scientists have been curious about for decades. One exciting find was active volcanoes on Jupiter's moon Io. The spacecraft's equipment picked up strange readings from the moon, and the images confirmed it, showing huge volcanic plumes and a surface that was constantly changing. One eruption on Io was said to be 1,000 times bigger than Mount St. Helens, covering an area about the size of France. As they went on, both spacecraft were slowly powered down to save energy before going into interstellar space. They didn't take pictures of Mercury or Mars because of tech limitations. NASA launched other missions, like Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 passed Pioneer 11 to become the most distant probe. Still, Voyager 1 kept going for another 14 years before actually reaching interstellar space on August 25, 2012. A useful trick for these missions was using the gravity of planets to slingshot the spacecraft toward their targets, saving fuel. They didn't just use engine power, they used gravity to pick up speed and change direction. This allowed them to go really far without using much fuel. When Voyager 1 was near Jupiter, the planet's gravity sped it up. Needed to be super accurate to avoid bad changes in speed or direction. Voyager 2 also used gravity from Jupiter and Saturn to get to Uranus and Neptune, showing the system works. Looking back at these great missions, the scientists are waiting for more info from the weird signals Voyager 1 is sending. These probes are still working beyond the solar system, checking out Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse videos showed 10 eruptions on Jupiter and found new moons and a ring around the planet, giving us better understanding. Voyager 1 also found 4 new moons of Saturn: Memes, Enceladus, Tuz, and Rhea, while also sending pics of the planet and its rings, showing how complex it is. The mission's trips to Uranus and Neptune gave us data about their atmospheres and moons, expanding our knowledge of the outer solar system. After flying by the planets, both probes aimed for interstellar space, where they're still collecting data. These studies give us perspective on what's out there. We look forward to hearing more about Voyager 1's strange signals and what they mean for how we understand the universe. These probes keep inspiring scientists and space fans. Their achievements help us to expand our knowledge and explore space. The Voyager projects have given us great views of the solar system and beyond, with pictures and scientific info. They also carried a symbolic message, something to share Earth's story with any aliens out there. The Golden Record has greetings in 55 languages, music, and sounds like thunder and whale calls. It's like a message in a bottle, hoping aliens might find it and learn something. Voyager 1 and 2 had great tools that improved what we know about space. They had magnetometers, plasma wave sensors, and imaging devices, which gave info on space conditions. The magnetometers helped understand the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, and how they work. Plasma wave detectors showed how solar winds hit planets. One big win was mapping the edge of the heliosphere, a zone with solar particles and electromagnetic fields that surround our solar system. As Voyager 1 got close, it sensed a change from solar wind to interstellar stuff, which showed how this zone protects Earth from cosmic radiation. The spacecraft found a spot called the termination shock, where solar winds slow down and thicken. Beyond that is the heliosheath, where solar and interstellar particles crash together. Voyager 2's got extensive to our understanding of the outer solar system. Its pass-by of the giant planets offered important observations, especially of Uranus's magnetic field, which turned out to be angled in a way that defied existing models. These findings have encouraged more study into planetary magnetism. These efforts have also got the public excited about space. The views of planets and the compelling stories have inspired many people. The pictures of Saturn's rings and Jupiter's moons have become iconic, and they continue to inspire space pioneers. As the Voyager crafts continue to relay data, their exploration of interstellar space offers opportunities to understand the universe. Though focus has often centered on planets within our solar system, studying interstellar regions has revealed unexpected complexities. Areas seen as empty display complicated phenomena that challenge scientists. Among the discoveries is cosmic rays from beyond our solar system. These particles moving at light speed offer hints about activity in remote parts of the galaxy. By studying their energy and makeup, researchers can learn about star-forming regions and galactic dynamics. As Voyager 1 and 2 head into interstellar space, their instruments continue to assess the density and motion of the interstellar medium, the stuff between stars. This stuff, made of gas and dust, interacts with solar wind and affects the heliosphere. The probes send back data that helps scientists model how energy and matter act between stars. The Voyager crafts have revealed magnetic fields in interstellar space, which may lead to breakthroughs in understanding cosmic magnetic forces across galaxies. This exploration shows us more and inspires future space researchers and engineers. The images captured by Voyager remind us of our place in the cosmos. These images and the advances have changed how we see our planet. The Voyager missions have opened the door to ambitious projects. With the created, sending advanced probes to space is realistic. Missions targeting exoplanets, places to live, and interstellar travel are goals for the future.